Okay, so question 7 is another vectors question. It doesn't really look like a vectors question, but it is, because they're asking us to find an angle with 3 coordinates. And some length of some lines. So first of all we've got the length of A to B is, we're using our 3D Pythagoras. So, well, first of all we need to know the difference between them, so how to get from A to B. So I'll just back up a second. A to B is, well, I'll give you a proper explanation as to what it is. If A is here and B is here, and here's my origin at O, and I want to know how to get from A to B. We know A and we know B. We know this and we know this. So I'm going to need to go back along here and then up here. So that's going to be minus B plus A. So I'm going to want minus B, which is this, plus A, which is this. So we get 1, 3, 9. So the modulus of A to B, the length of A to B, is now it's our 3D Pythagoras. 1 squared plus 3 squared plus 9 squared, which is 81, 82, 91. It's not the nicest number in the world, but doesn't mean it's wrong. A to C, following the same rules, is minus C plus A. So that's going to be minus 3, minus 3, minus 10, plus 2, 2, 5, which is going to come out at minus 1, minus 1, minus 5. Modulus of that is 1 plus 1 plus 25, which is the square root of 27. So we've got the length of A to B, we've got the length of A to C, we also need the angle BAC. So we now have, let's have A here in the middle, let's put B there and C there. It doesn't really matter where they are. We now have this vector here, and their lengths, and we're looking for the angle between them. I've made it look obtuse, we don't know if it is or not, doesn't really matter. It's important to make sure you've got A to C and A to B, because if you didn't, if you accidentally had worked out B to A or C to A, we would get the wrong side of the angle. They've specifically asked you for A to B and A to C, so that shouldn't happen. They've guided you through the question a little bit, which is nice. So we can now use our rule to find out the angle between two vectors, which is their dot product over their magnitudes. So, dot product of A dot B, sorry, AB dot AC is going to be, well, we've got them here, sorry, it's a bit awkward. We've got 1 times minus 1 plus 3 times minus 1 plus 9 times minus 5 we already know their magnitudes. We had root 91 and root 27. So on the top, what have we got? We've got -1, -3, that's -4, minus another 45, so that's -49 over root 91, root 27, and that is cos theta. So if we work this out and inverse cos it, and I'm going to do all that on my calculator now, I'm going to put my answer at my mode in degrees, so -49 over root 91 times 27, inverse cos of that, gives me an answer of 171.3. So 3 significant figures, that's 171. That seems like a pretty crazy angle, but that is correct. You could have given it in radians, which would have been 2.99, but I prefer these questions in degrees. So that's all of that first question done.